Good morning, everyone. My name is Ryan Agazi, and I'm the Teacher Development Manager for Macmillan Education International Curriculum. Today we have Mohi Uddin, who is our Singapore maths expert, who will be delivering the session today. And we are going to be focusing on decimals and percentages. So just to let you know in advance, if you have any questions, please do write them in the questions box. And also you won't be able to see each other's comments, so just be aware of that, just in case you're wondering why you can't see each other's comments. It's just the way the platform that we're using works. Also, CPD certificates will be provided within 1 week via email, so those will be sent to you within a few days, so just be aware of that as well. So I'm going to pass it over to Mohi now, and see you soon. Thank you.
Hi everyone, hopefully you can hear me and you can also see me. If you can just quickly type in a message just so that we're all ready to go and it's clear for you on your side as well, that'd be great. My name is Mohi, previously been a head teacher and head of maths, and for about 8 years now I have been training teachers all across England mainly, and for the last about 2 years now I have also been an international speaker with Macmillan and others as well, mainly in the Middle East and Europe as well again. So welcome to my my home. This is our a new kind of a venue, I suppose, for most people in England. Everyone is working from home because of the coronavirus, and hopefully you guys are all safe and sound at home, and we can get started with our webinar today. So today's webinar is all about decimals mainly, and we have also a section on percentages. Okay, so the first kind of thing we look at is the content of our session, focusing mainly again on decimals and linking decimals to fractions, looking at addition and subtraction, as well as briefly touching on multiplication and division if we have time, and then looking at variation as well before that, before moving on to percentages and finding a percentage of an amount and looking at visual ways to represent all of these concepts. Okay, so hopefully you have a good time and learn something that you maybe haven't seen before as well. This is our second webinar actually today. So our first one was about 2 hours ago, started 2 hours ago, finished about an hour ago now. And we had a really good time actually. We had a lot of our delegates, attendees, asking lots of questions and feeding back to us. Now, something that's really important for me, as well as probably most speakers that are delivering webinars, is that it's quite hard for me when I'm delivering something that's physical and face-to-face in a big hall, for example. I can see your face, I can see what you're doing, I can see how engaged you are. As a webinar, I can only see a screen, so and some comments sometimes in the question section. So what will be really helpful for the remainder of our session is whenever you feel like, oh, that's a really good idea, just type it in for me so that I know that you actually are benefiting from this and I'm not just talking on and on and on and on and on and never ending. Okay, so that would be really helpful. If you have any questions during the session, feel free to ask away. Try to make it specific to what we're covering rather than general ones. At the end of our session, we'll have a Q&A session, and that will allow you to ask more general questions as well. Okay, so starting off with our first question to you, I want to give you half a minute, maybe a whole minute. That's a long time in webinar speak. Okay, so I want you to think about this question in front of you. What is a decimal? What do you think about when you think about decimals? Okay, I don't want you to think there's a right and wrong answer here. Just want you to think about what you feel a decimal is and type in your answer in the question section. And then just send it over to me so that I can have a read. Okay, give you, let's say, another 30-40 seconds to kind of think about that and then type away. What is a decimal to you? Have you taught decimals recently? How did it go? Tell me about it. What things do you find a struggle with decimals? What do you enjoy about decimals? What have your kids said about decimals and so forth? That would be really helpful. So moral. Let me know how to say that, pronounce your name. It says fractions. So decimals part of fractions. Something that we're going to look at in a minute or two. What else? Anything else? A different way of representing fractions. Okay, thank you. Anything else? Maybe one more. Wait for one more. Different way of writing fractions is a valid answer. Thank you very much. It's also a way to write down numbers that are between. So, for example, we talk about half as 1/2, for example, right? But we can also talk about half as 0.5. Okay, so that's between 0 and 1. A half is between two numbers. So when we talk about, I'm glad one of our colleagues has mentioned the fact that, it's a different way of representing fractions, he says, okay? Or he or she, sorry, not sure. I can't see the gender there. So what is that? What is that? I mean, different way of representing fractions. That's a good point, but what does that mean? And that's where we can kind of go through this. So if this square was a whole, what would each of these represent? What would each of these represent in the whole? And so that's a question we might start off with, okay, with our children. So visually, we're trying to get them to think about this as a task. I've got this whole piece of paper, maybe, right? And I've folded the piece of paper into these shapes, okay? 1, 2, 3, 4, 5, another 5 here. I've got 10 of these, okay? I've got 10 of these shapes, and if you're not sure you can't see that, I'll show you like this, okay? I've got 10 of these shapes here. And I would ask, what does one of these shapes, what does one of these rectangles, what does that represent as part of the whole? And so children have a chance to think about that, and hopefully they'll say something like, oh, this is 1 out of 10 pieces, so we can call this 1/10. Okay, this piece is 1/10. Generally, when we talk about decimals, we kind of jump onto the fact that we've got 10th column, tenths, hundredths, and so forth, right? We jump onto that, but a lot of times our children don't really understand that language. Like they never think of the fact that they've used the word temps before. Like maybe you had some questions that went through temps, but they don't really link this temps as a fraction with this temps when we write it down as a word. And that's a big problem because we want them to know that they're the same thing, but a lot of our kids don't know that. So initially, we might start off with showing that this fraction temps can actually be written down without using the fractions. So how can I do that? We might write ones here. Some of us might be calling that units. Ones, there are 0 ones. We don't have any holes here, but this section here, we can say that's 1/10. And so we can write that down. 1/10 is 0.1. 1/10 can be written down as 0.1. What about, class, if I had another 10? How many tenths do I have now? Oh, I can see I've got 2 lots of tenths. How do I write that down? 2/10. We can write down 2/10 as 2/10, like this. So is there a way, do you think, you can write that down without using fractions as a decimal? There are no holes. I can see there's 2/10. We can write this down as 0.2. What do you think 3/10 would look like? Can you show me 3/10 with your paper? And so this is an introduction to decimals, thinking about fractions. And fractions is a major part of decimals, I'm sure you'd agree. But going around, not just in England, but going around the world, well, when we talk about fractions, decimals, a lot of teachers don't connect the two together well enough, so that life can be a lot easier if children who've been spending a lot of time learning about fractions, they realize that fractions and decimals are strongly linked. And so if you look at our textbooks, our student books, what you'll find is that the first page, for example, on decimals, looks at a visual way to understand decimals. And in fact, here you can see it says here, Padma folded a square piece of paper into 10 equal parts. She colored one of the parts. And there you can see Padma, and she's colored one part. And what that's telling you, so the books are fantastic at doing something for teachers. They're fantastic for planning your lessons. What do I mean by that? It should be obvious, right? Books should be used to plan. What I mean by that is the first part of every lesson clearly tells a teacher, this is how you can start your lesson. So in this example, what you might do is give a piece of paper, a square paper, to your children and ask them, can you fold the paper into 10 equal parts? And then they do that. And then you can ask them, or maybe you've folded it already for them. And then you can ask them, what does one of these parts equal to? 1/10. And then you can start to think about how you can introduce decimals. So here they've said, oh, this is how we can write down 1/10. We can also write down 1/10 as a decimal, which is 0.1. Why do you think it's 0.1? Because there is 1/10. What about 2/10? How would I write that down? And so forth. And then you can talk to them about the terminology used here and how we pronounce or how we say 0.1. Okay, 0.1 is written here. And so as a starting point, we can start to give our children paper, or if you have Deans, so what I've used in this app here is something called Dean's blocks. And most schools in England have Deans, but they're not widely used. Why? Because a lot of teachers haven't had training on Deans, or they just don't know, they don't feel that they need to use the Deans. They don't know how to get the most out of them, I suppose, right? And so the Deans are a really powerful tool for number work first, because each one of these represents a 1, and each one of these is a 10, and then you've got 100 and so forth. And the nice thing about this app, it's a totally free app. We're going to give you the name of the app later on, is you can break them down into 10s and 1s as well. Okay, there you go. And so we can use this not only for number work in terms of whole numbers, but also for decimals and fractions even. Deans is spelled D-I-E-N-E-S, sorry. Okay, so D-I-E-N-E-S. It's from a Hungarian mathematician called Zoltan Deans, if you're wondering. Okay, so coming back to this. So something that's also very important is, you can see at the bottom of this page is, okay, class, you can see 5/10, 6/10, 7/10, 8/10, 9/10. What about the last one? How many tenths is that? Oh, there's 10/10 there, but that's also the whole piece of paper. Can you see that? Great. So we can say 10/10 is equal to 1 whole. But how do we write that down as a decimal, do you think? And you can see at the bottom right-hand corner, we write that down as 1.0, okay? And we say it 1.0. And so obviously a lot of us here in this webinar are teachers who are teaching children maths in English, but English isn't their first language that they've learned. And so with English being a second language, it's so important to visually see something so clearly for them that they can understand what you mean by 1/10. 1 out of 10 pieces, that's 1/10. 2/10 is 2 out of the 10 pieces, and so forth. If we can visually show that, the language barrier that they have is not as huge as in some cases. Whereas if we just write down on our board and we don't really explain much, then what happens is it gets lost. It goes over their heads and they get lost in the language. And so visually, it's really helpful. And thankfully, because the Maths series of books follows the Singapore Maths approach, you're going to see a lot of visuals all across the book, not just for decimals, but all across every topic. And that's so important because in this case, for example, the decimal fraction link that we have is so important for conceptual understanding. And if we don't have conceptual understanding, then what tends to happen is some of our children will get it, like maybe a small percentage, 15 to 25% maybe of our children, they'll understand, somehow they'll get it, like they'll memorize what you're saying. But a large portion of your children just won't understand the language and the context you're going through. And so they will understand bits of it, and sometimes they get it right, sometimes they get it wrong, but they won't consistently get things right. And that's what's lacking, is that that conceptual understanding, the understanding the concept more than just understanding, oh, my teacher has done this way. I'm just going to follow them exactly how they do it. That doesn't really work very well. And we've seen that all across whole of primary, whether at a young age or at the end of the primary phase in primary 6, for example. And that's kind of quite clear when we go through questions like these and examples like these, where we know that a quarter, as an example, can be seen here in the first image in pink. That's a quarter of the whole piece of paper. But how is that 0.25, you might be wondering? How can a quarter be 0.25? I can see there are 1, 2, 3, 4, there are 5, 10, 15, 20. There are 25 of these small squares, but why is a quarter 0.25? That's an interesting question. How could I show this, class? Any hints? Any ideas? Let's have a look, okay? Let's get rid of all of this and let's start again. So this is our whole, okay? This is our whole piece of paper. And we're saying a quarter is, what is it, 25? 25 of these small squares is a quarter. Okay, so let's break this up and let's see those 25 pieces. Okay, that's 10, that's 20, and then I need five more pieces. So let's see, let me get a few of these. Okay, let's drag those 3 and this one 2 and this one. Okay, so these are the 25 pieces. Can you see that, class? Okay, class, this is a tricky one, right? Okay, so what did we say that these were? Let's see. Let's try to go through this together. What did we say these were? Oh, these were tenths, right? Why are there tenths? Oh, because I need 10 of these sticks to make the whole piece of paper. Okay, so let's see. So this is altogether 2 tenths. Okay, great. This is 2 tenths. What about this, class? That's a bit more tricky, isn't it? Let's have a think about this a bit more. So how many of these do I need to make the whole piece of paper? Each individual piece is going to be called, I need 100 of these. So this is 1 out of 100. This is 1/100th, that small piece. But there are 5 of these here. Also, we're going to call that 5/100ths. So I've got 2 tenths and I've got 5/100ths. Can you use your knowledge of fractions to solve that? 2 tenths at 5/100ths. I remember 2 tenths is equivalent to 20/100ths. And why is that? Do you know why 2 tenths is equivalent to 20/100ths? Oh, maybe you can see it now, huh? Can you see that, class? I can see 10 here. I can see another 10 here. 2 of those sticks is the same as 20 of these, and therefore that's 20/100ths. And I've got 5/100ths here. So altogether, I have 25/100ths. And 25/100ths can be simplified to 1/4. So that's why a quarter is 25/100ths. But 25/100ths, that's going to be easy for us to do now, right? 25/100ths is 20/100ths, which is 2 tenths. 2 tenths, so 0.2, and 5/100ths is 0.25. Remember the columns? This is the tenths column, and this is the hundredths column. And that's how we can kind of make sense of why a quarter is 0.25. And therefore, the other examples in a similar vein, we would go through the other examples. I'm not going to go through all three of them because it just take a long time to go through all three. But you can kind of envisage how we can go through this key concept that a quarter equals 0.25. What have we done there? Oh, we've made a quarter into something out of 100, okay? And that way we can easily work out what the decimal equivalent is. So I'm going to give you 30 seconds just to digest that. And if you have any questions, just to throw them at me so that I can also kind of just go through reading your kind of solutions. Okay, so someone's asking, could you please spell the Deans, D-I-E-N-E-S? Thanks, please. Could you insist how important the children visualize tasks which resources in language should be a barrier. So Esther is asking, please could you insist how important is that children visualize tasks, materials, resources, language shouldn't be a barrier. Yeah, I mean, the more visuals you have, the less of a barrier language would be. Okay, that's so essential. If you are teaching children in English and that's not their first language, then what we need to make sure is that we have a visual representation of any technical words. They might know the basic words that you use everyday language, but technical words like tenth and hundredth, you're not going to use that in everyday language. So the more visuals you have along with the fact that this is a tenth, oh, you can see it here in this picture, this image, this concrete part, you can see it, the easier your life as a teacher will be. How would you explain 2500 is a quarter just by the image? So Monica, hopefully you saw you saw how we did that using the app, and hopefully that's clarified that question. And the app is called Number Pieces. Okay, it's going to be in the PowerPoint presentation that we're using, and that's going to be sent over to you by Rainer as well. Okay, so we're going to go back to our session and our PowerPoint, so our presentation. So let's move on, and then you can see here that the books move on. What happened here? What's the difference between this page and the previous page? Can you see any difference? This page is the page that we've been looking at, and the previous page we've been looking at, and the previous page to that is something like this. And so you can see that this page, these two pages, and this page, and this page, they are very visual, but then suddenly, a few pages down the line, there's not much visual here, right? What happened? The reason there isn't as many visuals here is because we want our children to follow something called a CPA approach. Does anyone know what the CPA approach is? That's a question out there for you. I'll wait for you to answer that. Who knows what the CPA approach is and what does it mean to you? I'll give you a few seconds to answer my question. If you don't know, just say, I'm not sure, I've never heard of it. It'd be good for me to know that as well, because then I won't have to just pretend that you know what it is. Okay, great. So Venus, thank you very much. She says that the CPA approach means the concrete, pictorial, abstract approach, and CIMAB also says the same thing, abstract approach. It's not abstract approach alone, it's the concrete, pictorial, abstract approach. What does that mean? It means, so if you've been into any of our webinars before, we go through this pretty much every webinar because it's such a fundamental part of the Singapore approach. It just means that you start off using concrete materials. So in this example, Decimal's example, what was the concrete? Can you remember what the concrete material I used? Obviously, I can't use it here, but if I was to use a concrete material, what was the concrete material that I would have used for the decimals? Perfect, Monica. Well done. And Vina as well. So both of you are correct. Okay, so Monica says paper and Vina says the blocks. Okay, and both of you are perfectly correct, because with your children, if you don't have the blocks, you can use paper. If you have the paper and the blocks, you can use either. It's up to you. Okay, and the beads too. Beads beads would be a bit more challenging, I think, to kind of visually see straight away the hundreds, the whole, the tens instantly. So that could be a bit more challenging, but it could work definitely, because some beads, they don't go up to 100. It might go up to 50, for example. Okay, so it just depends. And the beads that we use here, I actually got one right in front of me. Hopefully, you can just about see that. Here, let's see which one, how much does this go up to? That's 10, 20, 30, 40, 50, 60, 70, 80, 90. This one's 100. Okay, so this is a perfect one. This is 100. But you can see, look what I'm doing. It gets a bit, it gets a bit messy, right? You can see I'm like dangling them around. It's a bit too long, and so that could be a bit of a challenge depending on how your class is. So the question was, what did we use first? For concrete was paper and the Dean's blocks. Then the pictorial representation could just be something like this. It could just be an image like this, yeah. And you could use that. That's also fine. And then the abstract is where we're here now. Okay, that's why we're here. The abstract. The abstract is where we want our children to get to, right? We don't want them to always stand or stay using the concrete and pictorial. The aim is for us, the CPA approach, is for us to get them onto the abstract and not just let them linger in concrete and pictorial. And the way we do that as teachers is, some children would naturally say, "Oh, miss, can I please go on? Do I have to draw it out again, or do I have to use the paper?" And then you know that they're ready, they can go on. But some children are so attached to the paper, you need to give them that confidence by just saying, "Well done, I can see you've really understood this. Can you try to do it without the paper? If you need to draw the image, you can draw it." And then the next phase is, "Oh, you've been drawing the images, which is beautiful. Your page looks absolutely amazing. But now I think you're ready to complete these questions without drawing the image. Can you try that out and see how they get along?" But if you get stuck, what can you do? You can draw the image again, right? If you get stuck. So you can kind of encourage your children with these types of questioning and words as well. Okay, so what about the hundredths? We've kind of looked at the hundredths, and the books are absolutely fantastic for that, because as a teacher, you've got, I don't know how many subjects, because in England we primary teachers, we teach 6, maybe 7, 8 different subjects. Okay, and some of us have we're quite fortunate that we only have to think about maths, for example. Okay, but most primary teachers have to think about 6+ subjects, maybe even more. Let me know how many subjects you teach, just to kind of get a grasp of, because we've got people from all over the world in this webinar, which is so fantastic. And so let me know how many you teach, how many subjects you teach as a primary teacher, and what country you're from, in the same text and same question. That would be really good to kind of know. So why am I saying all of this? Because when we have 6 subjects or more to teach, what tends to happen is one at least of the subjects, probably more than one, gets slightly neglected. Typically the one that we're not very confident with. Okay, and it could be maths, it could be other subjects as well. And what that tends to mean is that we don't have as many ideas about how to bring the lesson to life. Yeah, and if that's the case, then our children will be slightly suffering, if that's the right word. They won't get as much out of the lesson as you'd hope, and therefore we kind of let them down a little bit, right? Or a lot sometimes. And so the books are absolutely fantastic because they give you the ideas. And webinars like this give you a few more ideas, like, for example, the app that I showed you, right? Maybe you've never seen the app in your life before, but seeing this page in the book and seeing the app that I used, you can see hopefully yourself using the app to going to go through these lessons. And just like the way we went through 0.2 and 0.25, you can see the way they're doing this in 0.1 and 0.2 on the second page as well. And looking at the fact that 0.26 is the same as 0.2 at 0.06, which is 0.26. If you've got any questions, let me know, and we can definitely go through them. If you are a teacher that now are going to be teaching a bit more advanced decimals as well, so we're talking about numbers that have not just tenths, not just hundreds, but also thousands as well. Okay, then we probably would use the actual Dean's blocks, the big blocks, the thousand. Normally we call them the thousand blocks, and we'd say actually instead of thinking about it as 1,000, we'll think of it as one. Okay, this is one whole block, and then therefore ask the children, oh, how many of these red flat packs do I need to make the whole of that one block? And we will know that, that's one, I need 10 of those. Oh, so that must mean that this red block must be 1/10. And the blue ones, I need, how many do I need? 10 of those blue ones to make the red one. I need 10, that's 100. So the blue ones must be hundredths, and the green small blocks in this case are going to be thousands. I need 1,000 of those green small blocks to make the whole big yellow block. So that becomes thousands. Is that okay? Is that quite clear? And so when it comes to comparing numbers and understanding what would like these 4 flat packs be, oh, that's my, I need 10 of these to make the block. That's my tenths. So that's 4 tenths, for example. And then you can ask your children different questions, looking at different images. What about this? I've got a tenth here. I've got 1, 2, 3, 4. I've got 5 hundredths, is it? So a tenth, 5 hundredths, and I've got 3 thousandths. So would it be what, 0.153? Can you see yourself writing that down? 0.153. This is my tenths. These are my tenths, hundredths, and thousandths. And therefore, you can see that I've got 1 tenths, 5 hundredths, and 3 thousandths. Remember, I need 1,000 of these to make the big cube, right? And therefore, this is 3 thousandths. Does that make sense? So, some questions that you're asking some of us are not related to specifically decimals. So I'm not going to answer them as such in this webinar, but maybe in a future webinars we can do that. But we are going to look at adding and subtracting as well. Okay, so don't worry, and multiplying and dividing. So relational understanding. So something I picked out is so important for our children, like we've done here, to see a relational understanding. Can you see the relationship between the 3 and the 3,000, excuse me, and the 5 and 5 hundredths, and the 1 and the 1/10ths? That relationship, visually seeing that relationship, is so important, because without actually understanding decimals, you're going to lose your children. Yeah, because they just start understanding the language. You're never going to use this language, hundredths, tenths, thousandths, in your everyday life. Okay, so therefore it's so important. So some of you are asking, what's the name of the app? Okay, so just to kind of summarize what we've looked at so far. Firstly, we looked at tenths. We use the Deans, the blocks, and we use paper. You can do that in your class, and you can also use the app called the Number Pieces app. Okay, that's the name of the app, Number Pieces. So if you just type it on Google search, it will be the first one up there, and it's a free resource to use. You can use it on your browser if you wanted to, or you can download it onto Google Chrome, and therefore you don't need the internet. Once you download that, you don't need the internet, and you can just use it without the internet. We know in schools sometimes the internet goes down, and that's a horrible feeling when you need it. So it's better to kind of download it, in my opinion. I'd rather not take the risk. And then the hundredths, the same. And for thousandths, you can use the Dean's blocks. Okay, the 1,000 block is your 1 in this case. We talked about variation at the beginning of our session. And here we talk about variation in terms of, if you see the images we've been using, we've got different images. We've got images that are circles, rectangles, but then the rectangles also, we've got some that the tenths are going across, some of the tenths are going vertically. And so that difference is what Zoltan Deans talks about, as well as difference here. You can see the not Deans, excuse me, you can see the decimals on a number line as an example. You can see the decimals with inequalities, for example, that you probably have looked at inequalities before already. And therefore, when Zoltan Deans talks about some of his theories in terms of variation, he talks about systematic variation, having some variation in the way you're questioning your children. So if you just ask the same question again and again and again and again, but just change the numbers, it's boring. You might ask it twice or three times even, but then we need something to change that. We need something to kind of make them think a bit more by changing that question and varying the question. You might do the other way around. You might have a missing part, but having that variation is important. And then perceptual variation, multiple embodiment. Multiple embodiment means seeing the maps in different ways. So for example, it might be circles, it might be vertical rectangles, it might be horizontal rectangles, it might be number line, it might be with inequalities. Seeing decimals in different ways is something that we have to encourage, because if we only see decimals using, let's say, paper or the Dean's blocks, what's going to happen? What do you think is going to happen? They're only going to be used to the Deans. They're not going to know any other way of seeing decimals, and that's something we need to be really, really careful about. Okay. Right, so where were we? Okay, so that leads us to ordering decimals and seeing decimals in this way. So when we see decimals using visual representations, can you see how easy it is to order decimals? Like, can you see how 4 tenths here in the middle is much larger than something like this? Because what is this? This is 0.1, 1, 2, 3, 4, 5, 153, right? We've done that already. So this is 0.153, and this is 0.4. Can you see how children might think that 0.153 is larger than 0.4? But you can see here, visually, 0.4 is much larger than 0.153. But 153 is bigger than 4, right? So there's those obstacles we have to face when we teach decimals, but it's easier to face them not just using language, because that is tricky if we can't see it, but seeing the visuals makes that a much easier task. Just a quick look at the time. Okay, we've got about 15 minutes or so to kind of go through this before we get into a Q&A session. So looking at adding and subtracting as well, let's have a look at this question. Let's say it's addition. So when we look at addition, we can look at it straight away if you want. 0.25 add 0.2. Straight away, I mean using column addition. Okay, how many hundredths do we have in the second number? Oh, we've got no hundredths, so we can put a 0 there then, can't we? Okay, now just check my audience can see this. Yeah, that's fine. Okay, so when we add this together, if we just jump onto the column addition, that's not as helpful as using a visual approach first. This pretty much looks like column addition, right? How many hundredths are here? 5, 1, 2, 3, 4, 5. 5 hundredths. There are no hundredths here. So altogether, how many hundredths is that? That's 5. And how many tenths do we have here? 1, 2, 3. That's 4 tenths. So what's this number? 0.25 and 0.2. 0.25 add 0.2, 0.45. When we write this down, adding the hundredths, can you imagine the hundredths? Adding the hundredths, we get 5. Adding the tenths, we get 2 tenths, add 2 tenths, 4 tenths. Are there any whole numbers here? We don't have any whole cubes, so we're good to go here. 0.45. Does that make sense? Let me know if that was clear or if that was something that wasn't very clear for you. Let me know also if that's something that you'd like to, you are planning to use now, something like this to show your children when you next teach decimals? That would be really helpful for me to understand your thought about this whole webinar as well. Subtraction is exactly the same. With subtraction, I remember once I went, because I was a head teacher for 2.5 years before I became a consultant. So in that time, I remember observing, actually, no, it was in my consultancy time that I remember observing a teacher, and we were encouraging everyone to use the CPA approach. And it's quite new at that time in England as well, to a lot of our schools. Okay, now it's been a good 6 years, 7 years since those schools have started to use the CPA approach, and things are a lot more efficient. And so when it came to subtraction, something like 0.25, let's say, for example, take away 0.2, what we don't want to do is show 0.25 and show 0.2. We don't need this at all, okay? This is here, I can't get rid of it at the moment. So imagine this is not here. All we need is 0.25 because I'm going to subtract 0.2 from that. If I have another 0.2 and I'm subtracting, it makes it look like 0.4, right? And we don't want that to happen. So all we need is this for subtraction, 0.25. Right, class, can you see that we're going to subtract 0.2? Are we subtracting any of the hundredths? Oh, we're not subtracting any of the hundredths. So if I've got 5 hundredths already and I don't subtract any hundredths, how many am I going to be left with? I've got 5 hundredths left. Now I've got 2 hundredths here, and I've been asked to subtract 2 hundredths. What does that mean? Oh, that means I'm not going to be left with any hundredths. And do I have any wholes? I don't have any wholes. So what am I left with? I'm left with 0.05. 0.25 take away 0.2 is 0.05. Does that make sense, class? Let me know what you think about that. Okay, so coming back to the next part, right, of our presentation. Okay, let's look at a quick look at time. Okay, got enough time. Right, so multiplying and dividing. Okay, so multiplying and dividing. So let's have a look at this, and we need to make sure. Okay, we need to make sure that we understand multiplying and dividing really well. I'm going to look at basics of multiplying and dividing for today, because we're going to run out of time for percentages if I don't. Okay, so let's say we've got that's our tenths, and we've got, let's say, 2 hundredths. Okay, so I've got 0. Let's do it. How much? Okay, right. So I've got 0. Let's move this out of the way. I've got here 0.12. Okay, check the. I've got 0.12 in front of me. If I say 0.12 times 2, how would I show that? Well, that would be really easy because all I'm saying is 0.12, and I'm going to have 2 lots of 0.12s. So if I wanted to, I could maybe even change the color and say this is another 0.1 and another 0.02 here. So 0.12 times 2 looks like this, 2 lots of 0.12. Just like when we talk about multiplying 5 times 4, we can show 5 lots of 4s or 4 lots of 5s. We want our children to do exactly the same, visually thinking about decimals as well in the same way. Can we show 0.12 times 2? Yes, we can. 0.12 is here, and 0.12 times 2 is all of this all together. So what does that mean? 0.12 times 2 is 0. Let me write that down. Is 0.24. I can see 0. There's two tenths there, and there are 4 hundredths, 0.24. So when we look at this using column multiplication, that can also be quite simple if we use visuals first, and that way our children get to see the abstract approach more clearly, because you can put them together and then they see why we're doing each part. Okay, similarly with division, if I refresh this, exact same approach for division. If I have 4 hundredths, and let's say and I have 6 so 4 tenths, I should say, 6 hundredths. There we go. If I have all of this here and I say, what is this again? 0.46, right? 0.46, and I divide 0.46 by 2, okay? Then I can say, well, if you divide the tenths by 2, I've got 4 tenths. What's 4 divided by 2? It's 2, right? So 4 tenths divided by 2 is 2 tenths. And I've got 6 hundredths here. 6 tenths, 6 divided by 2, 6 hundredths divided by 2 is 3 hundredths. 1, 2. So I've got 3 hundredths. So 0.46 divided by 2 is equal to where's my pen? 0.23. So we don't want to, we want to try to keep this as really simple as possible. And when we have, even with multiplication, when we have more than 10 tenths, for example, okay, or 10 hundredths, for example, what we can do, let's show you what we can do. If we have more than, let's use this to make it a bit quicker, okay? So if we have more than 10 tenths, so let's say we're adding these together, okay? So let's say we have something like, I don't know, yeah, okay, so we've got 8, this is 8 tenths, add 5 tenths. We can see altogether 8 tenths and 5 tenths, when we put them together, we have more than 10 tenths. What did we say 10 tenths was, class? We said 10 tenths is a whole, right? So all of this together, if I do this properly, will be 1 whole and 3 tenths as an example, okay? Similarly, we can do that with hundredths and thousands and so forth. So we're going to move on because we're kind of running out of time. And just want to finish off really. What's the time now? Let's see. Okay, we've got about just under 10 minutes before Q&A session. Let me quickly have a look at my questions at the same time. So we're going to move on to percentages. With percentages, so with percentages, I'm going to answer some of the questions that have come up. So with percentages, I wanted to kind of go through this one key example as well. So in the books, again, visuals are so important. I can't, emphasize this enough really. Here we've got 100 eggs, out of which 1, 2, 3, 4, 5, 6, 6 are brown, the rest are white. Okay, and what happens here is, we're already kind of thinking about 100, right? We know percentages out of 100. So when we talk about out of 100, it makes it easier for us to kind of think about percentages. So the book starts off 100. We talk about our 6 out of 100 is 6 out of 100 as a fraction, 6 hundredths, which is 0.06 as a decimal. And we say as a percentage, that's 6%, because percentages are out of 100, and this is already out of 100, which is ideal for us. And then the book can move you on to percentages that are not out of 100. For example, if it's out of 50, then how do we make that out of 100, class? We can make, if it's out of 50, if it's 4 out of 50, then we know 4 out of 50, 4 50ths, is the same as 8 hundredths. Our 8 hundredths is 0.08 and 8% and so forth. But that visual connection between 100% and 100 out of 100 is there for you to see clearly, and in the books is really important. The kind of last, I think the last kind of questions we're going to go through, we've got 6 minutes before Q&A, so just about enough time. The last questions we want to go through is a percentage of an amount, okay? Have a look at this question, and I can quickly look through your questions that you have as well at the same time. Can you try this out? But when I say try out, I don't mean, as teachers, we're going to know the answers. That's not what's important to me. That doesn't really matter at all what the answer is. But what I'm saying, how would you kind of show this question to your children? What strategies would you use to solve this question? Find 20% of 50. Have a go at that, and let's see what you come up with. So let me know what kind of strategies you would use. Yeah, Monica, that's a good point actually. I think I pressed the delete button, so I just went with I went with delete. It is better to group them, and I totally agree with you, Monica. Yeah. So for division questions, I would rather group them, like I did in my last webinar. But in this one, I pressed the delete button just by, I don't know if it's accident or I just didn't think about it, and then I had to kind of go with that. So I apologize for that. But it would have been better to kind of group those questions of division that I looked at just a few minutes ago. So thank you for that, Monica. Oh, great. Perfect. Okay, so right, so have a think about this question. Find 20% of 50. So in our last kind of webinar, what we talked about was how this type of question, we would do something like 50 divided by 100 times 20. And that's all good and well, that's fine. It's a formal approach. We want our children to know the formal approach. But it might be a huge jump straight away. Like, how would I explain that? Okay, so for questions like this, where you're finding a percentage of an amount, or even a fraction of an amount as well, it's really easy to use something called bar modeling. Okay, and I want to show you how easy it can be. So if this is a bar that represents 50, then this is 50, and also if it's 50, then it's also 100%. Okay, that's 100% of 50. And so what will 20% look like? Well, 50% is halfway. 20% is about, let's say, about here. Okay, maybe not that one actually. Let me just make it a bit bigger. Okay, it's about there. Okay, 20, 40, 60, 80, 100. Okay, let's see if that's right. 20, 40, 60, 80, 100. Yeah, so this is 20%. Okay, let me get rid of this. So this is 20% of 50. So you can see that there are 5 lots of 20% to make 100% of 50. So we can just actually do, to work out 20%, we could do 50 divided by 1, 2, 3, 4, 5, divided by 5. 50 divided by 5 equals to 10. So this must be 10. Let's see if that's right, because that's 10, that's 20, 30, 40, 50. So that's altogether 50. 20% of 50 must be 50 divided by 5, which equals to 10. There's more than one way of using the bars, though. That's the really beautiful part about the bar model approach. And Macmillan Education have actually got bar model packs that your school can purchase. I think they're digital packs, and you can use them really quickly and easily in your school, and it can help you in many different ways. So here, 20% is what we kind of focused on because the question talks about 20%. But you can actually change that around and you say, well, if that's 20%, if these are 20%, then half of that must be 10%. So we've got all of these are 10%. So 50, and there are 10 here, 10 bars of 10%, that makes 100%. So 50 divided by 10 is 5. So each of these must be 5. So 10% of 50 must be 5. So 20% must be 20. So 20% must be 10, excuse me. 20% must be 10, okay? So that's another way. 20% of 50 equals 10. So that's 2 different methods you can use using bar model. But there's a third method as well, okay? So in this question, 15% of 40, for example, we can look at a whole bar and say, well, that's 40. And we can say, let's think of it as 10%. Let's think out 20% first, 20, 40, 60, 80, 100, and 10% would be something like this. So we can think of 10%, and then we can work out, well, 40 divided by 10 equals 4, and therefore 15%, so each of these are 4, and that's 10%, so 5%, must be half of that, must be 2. So that means 4 plus 2 is 6. So 15% of 40 must be 6. Hope that makes sense. But because we're looking at 10%, we're saying how many 10% make 100? That's why we have 10 of these blocks, because 10% make 100. But then we might ask another question, okay? Because we want them, because if it's something like 17%. That's a bit more challenging, right? So we might want our children to think of a unitary method. The unitary method is thinking about units, okay? So in this case, 1% is our unit, okay? So if we know that there are 10 lots of 10% to make 100%, how many of these 1% do we need to make 100? And children should be getting to understand that there are 100 lots of 1% to make 100. So 1, 2, we can go on forever here, right? I'm not going to do 100 because we take the rest of our session and more. So there's 100 lots of 1%. So if I wanted to work out 1%, I have to do 40 divided by 100. That will give me just the 1%. And then, we know 40 over 100, we looked at decimals just now, right? 40 over 100 is 0.4. Okay, so 1% is 0.4. We need to work out 15%. 15% is going to be 15 lots of 1%. And 1% we know is 0.4. So it's going to be 15 times 0.4. And we work out that that's 6. Okay. And so that's another method. That's called a unitary method, where we work out 1%, and then we can work out whatever we want to after that. I'm going to stop there, and we're going to move on to our kind of summary of our session, and then our Q&A session as well. We've got about 4 minutes left. Okay, so this is running just slightly out of time. Okay, so just to kind of summarize, we talked about the CPA approach, the concrete pictorial abstract approach. You can find out more about that by researching Jerome Bruner, excuse me. And then we didn't speak much about this today, but we always talk about the core essentials of Singapore maths, which is representation, visualization really, generalization, trying to encourage generalizations as much as possible in our lessons, understanding numbers, number sense, and communication, allowing our children to communicate with each other, as well as communicate with us, giving us their thoughts and ideas, as well as metacognition, which is to think more about their thinking rather than just doing what the teacher says, but thinking more about why they're doing things as well. Just remember that seeing maths really helps us to understand maths. Okay, seeing maths helps us to master maths at the end. We're going to start our Q&A session, so feel free to write down as many questions as you want. I'm going to try to keep it to about 3 to 5 questions though, so I'll pick out questions and try to go through them. I'm going to move over to the questions. Oh, there is. Let's see what we've got here. Okay, so how can we, so Feroz has asked, how can we use this method to show decimal representation when we divide a number by another number? Okay, so that's a really good question. So if it's like 5 divided by 3, for example, yeah, or 10 divided by 4 as an example, is that what you mean, Feroz, right? So 20% of 13, I think I've gone through that example, like the unitary method, so you can think about that for 20% of 13. But in terms of your first question, Feroz, how can we use this method to show decimal representation when we divide a number by another number? So that's a really good point. So if we look at 10 divided by 4 as an example, we can do that really nicely actually. Okay, so if you have 10 divided by 4, we know that for example 4, 8, then you've got 2 remainder, right? So you've got 4, then you've got 8, and then you've got 12. So we know that 2 remainder 2, but that remainder 2, okay, that remainder 2, we've got 2 here. If this is 2, we're dividing 2 by 4. Okay, that's our 2. We're dividing 2 by 4, and therefore we've got 2 here. We're dividing by 4. We've got this section here. Okay, what's that? So then you can think about, if that's 2, that's 1, that's going to be a half. Is that right? That's going to be 2, that's going to be 1, at 0.5, 0.5, 0.5, 0.5. So it'd be 2.5. Okay, so we can use the fact that the decimals can be divided and use a visual representation like a bar model, for example, to show that. Okay, and that's an important part of decimals as well. I think at your, it depends on what curriculum you're using. If it's a Cambridge curriculum, I don't think they use that as much. We have got examples of that in our book, so you can go through the examples and you can see that as well. Any other questions? Okay, I can't see any more questions. So I think we will possibly stop there. It's past, and there's no more questions. So we'll probably end our session. Thank you, Monica, for your lovely comments and others as well. Hopefully you've benefited from this session and you can then take this on further in your lessons. I know we've got further webinars planned in September, October, and maybe one or two before then as well. And Rainer can give you more information, I'm sure, about that. So I think we will stop there. Rainer, if you'd like to take over.
Perfect. Thank you so much, Mohi. Really, really useful. We had a session in the morning. It was really great. So thank you once again for all the informative information. And I think the teachers, as you can see from some of the feedback, is really beneficial. So thank you once again. And thank you to the teachers. Like I said in our morning webinar, it's a strange time at the moment where most of you are probably at home. So we really hope that you found it engaging and informative. So Mohi's just going to show you the next slide with just some of the key information on the website. Information if you'd like to contact us, please refer to our website. You can gather all the information from there. If you have any questions regarding future webinar topics or resources, please do feel free to email us. And also previous webinar recordings and additional videos are all on our Macmillan Education International Curriculum YouTube page. CPD certificates, as mentioned, will be provided via email within a week. So do look out for those. And as Mohi mentioned as well, we do have upcoming webinars. So when you do receive your certificate via email, you will be prompted with further webinar information as well. So thank you once again to Mohi. Really, really amazing webinar. And thank you to all the attendees as well. We hope you enjoyed it and see you soon. Thank you very much.
Thank you.
Bye.